Okay, so I'm going to work out the 18 multiple choice questions for Unit 3. The first question says that if g of x equals ln of x, and f is a differential function of x, which is the following. Okay, so f of g of x can be rewritten as f of ln of x. And they're asking us to find the derivative of that guy, right? So from the chain rule, we know that the derivative would be f prime of ln of x. And understanding that the inside term is complicated, it's not an x term, we have to bring him out and take the derivative of that guy. And so that derivative would give us 1 over x. So at the end of the day, what we would get is f prime of ln of x all over x. That's the answer we're looking for, and there it is. Okay, so that doesn't have it, that doesn't have it, that doesn't have it. Number 2. For which of the following functions is the chain rule an appropriate method to find the derivative with respect to x? So which of these would require the chain rule? Well, when we work through it, this one is a chain rule because the inside is complicated. So cosine of 3x squared times 3x squared prime, right? So there's the chain rule. The second one is not a chain rule because we would just use product. First times the derivative of the second plus the second times the derivative of the first, which is e to the x, right? So this is not a chain rule. And then finally, the third one, this is a chain rule because this can be rewritten as 8x to the fourth minus 2x to the negative first power. And so we see that this is a complicated expression. And when we take the derivative, negative 1, 8x to the fourth minus 2x to the negative second, and then remember that the derivative of this, okay? So the answer would be 1 and 3 only. 3 only. Okay. Number 3. Let f be different. H of x equals this, which is the following h prime. Okay, so the process here. So h prime 2, 1 plus f of 3x to the first, right? So there it is. And then we have to remember to multiply by the derivative of that, 1 plus f of 3x. This is to the first, and then so the derivative of this would give us 0 plus f prime of 3x. And then we need to remember that this is complicated, so multiplied by 3. So really when we write this all out, it would give us this right here. Okay, so that's number 3. Number 4, what is the slope of the line tangent? So we're going to take the d dx of each term, so y cubed minus d dx of xy squared plus d dx of x cubed equals d dx of 5. So 3y squared dy dx minus first times the derivative of the second, 2y dy dx, plus the second times the derivative of the first, which is 1, plus 3x squared equals 0. And so now I can do some sorting out and factoring. So dy dx, 3y squared minus 2xy equals negative 3x squared plus y squared. And then from there, I know that dy dx equals negative 3x squared plus y squared over 3y squared minus 2xy. And I'm going to evaluate that at the point 1, 2, which gives me negative 3 plus 4 over 12 minus 4, which is 1 over 8. So there's my answer. Number 5. Sine of x plus y equals 3x minus 2y. So that's an implicit differentiation problem again. So we're going to derive each one of those. So sine of x plus y is cosine of x plus y times the complicated term, which would be 1 plus dy dx. Because every time we take the derivative of a y, it would be dy dx equals 3 minus 2 dy dx. So if I factor out the dy dx, I'm left with the cosine of x plus y. And then I'm going to move this guy over like that, equals 3 minus cos x plus y. And then dy dx equals 3 minus cos x plus y all over cos x plus y plus 2, which looks like answer choice part D, okay? All right, the next part, the point negative 2, 4 lies on the curve in the xy plane given by the equation f of x. Okay, g is, okay, what is value of dy dx? Okay, so this is not fun. What is the value of dy dx at the point negative 2, comma 4? Okay, so I see. So this is an implicit differentiation problem. So let's do this. This is probably the hardest one I've seen so far, but it's not too bad once you understand all the language here. So what they're wanting us to do is to do this and to take the derivative of each term. 17 minus the derivative of x minus the derivative of y. So first times the derivative of the second. And then remember, every time we take the derivative of y, we have to remember the dy dx plus the second times the derivative of the first equals 0 minus 1 minus dy dx. There we go. And so now what I'm just going to do is I'm going to isolate the dy dx's. So dy dx, f of x, g prime of y, plus 1. And that 1 came from right here, okay? Equals negative 1 minus g of y, there we go, f prime of x. And then dy dx equals negative 1 minus g of y, minus g of y, f prime of x, all over f of x, g prime of y, plus 1. And then they want us to evaluate this at negative 2, comma 4, or in other words, when x is negative 2 and y is 4. Okay, so that becomes negative 1 minus g of 4 f prime of negative 2 over f of negative 2 g prime of 4 plus 1. And then when we refer up to our chart, it gives us all these terms. So g of 4 being 5, f prime of negative 2 being 4, f of negative 2 being 3, g prime of 4 being 2. And so this becomes negative 1 minus 20 over 6 plus 1. So negative 21 over 7, which is negative 3. And there's our answer. Okay, so that one was probably the hardest one so far. But yeah, okay. So our number 7 or whatever this is, the graph of a decreasing differentiable function is shown above. Also shown as a line tangent. Let G be the inverse. Which of the following statements about G prime is true? Okay, so this is a dead giveaway that this is one of these problems. And they're asking us to figure out what G prime is, which is f inverse prime of x, which is that rule 1 over f prime of f inverse of x. Okay, now they want us to figure out either at 4 or at x equals 6, right? So that's what we need to consider. So let's see. Okay, okay. The first thing to consider is which one of these is true, right? So for example, if we were to consider the case G prime of 4, that would become 1 over f prime of f inverse of 4. So when we look back at our graph, at f inverse of 4, we're considering the scenario when the y is 4. And in this case, that will be over here, but this doesn't relate to the problem that we're doing. Do you see that? So we can eliminate these cases. What the case that we would want to consider is g prime of 6, which is 1 over f prime of f inverse of 6. And so f inverse of 6 comes out to 4 because that's the y value, right, of 6. That gives us 4. And then we want to consider 1 over f prime of 4, which is basically asking us what is the instantaneous slope at 4. And the instantaneous slope at 4 is whatever this, so it looks like it's down 3 and over 4. So it looks like that slope is down 3 and over 4. So when we take the reciprocal of that, that'll be negative 4/3. So that would be our answer. Okay, so that's number 7. All right, let f be the increasing function defined by that. If g is, okay, so here's another one. All right, so g prime of 2 would be 1 over f prime of f inverse of 2. Okay, so now we just need to work that out. We know that f inverse of 2 is equal to negative 1. How did I know that? By looking right here. So then that becomes 1 over f prime of negative 1. So to find f prime of negative 1, I need to find f prime. So f prime of x will be equal to 3x squared. And how am I doing this? I'm looking right here. 3x squared plus 4x plus 4. F prime of negative 1 is 3 minus 4 plus 4, which equals 3. And so my answer is g prime of 2 equals 1 over 3. Oh boy. Okay, so, gosh. Oh, I see. So we're good with that. So there it is. Okay, so we don't need to bother. So that's why it helps to look ahead at your answers, which I didn't do. All right, the table of g f inverse, which is falling to g prime, is the same thing. So 1 over f prime of f inverse of 2. So when we look at our graph, here's f inverse of 2, which gives us 4. So 1 over f prime of 4 gives us 1 over negative 5. And I got that from right here. There it is. Okay. Oh, fun. So this is just 1 over square root of 1 minus x squared interpreted at x equals 1/2, which is 1 over square root of 1 minus 1/4, which is 1 over the square root of, and let's see if any of these other, there it is. Right? And so this one is like the same thing, but it's negative square root of 1 over 1 minus x squared. So that's just a rule to know. Okay, that was a fun page. Which of the following methods can be used to find the derivative? Okay, use a quotient rule to differentiate. Oh my gosh. Okay. So no, that's not true, because a y equals inverse sine is not the same thing as saying that it's 1 over sine. It's not, this is not an exponent. This is not an exponent, right? So when we say negative first power, we think, okay, I'm going to put that over that, but this is not what that is, okay? So we can't do that. So 1 is already out of the equation. So we're down between 2 and 3. So we already know 3 holds because 3's are our options, but we're going to use a chain rule to differentiate. That's a weird method. Well, let me see here. So y equals inverse sine of x. So one thing I can do is I can change this so that the sine of y is equal to the sine of arcsine of x. And so that changes to becomes x equals sine of y. So this question is asking me, use the chain rule to differentiate. I don't know why I would use a chain rule here. I don't know how that would be helpful for us. Okay, I'm going to roll with 3 as my answer, but we may have to double check that. Let me go ahead and just, I haven't really thought through this problem per se, but I would roll with something like that, I think. Yeah, and you know what, I'm pulling up the answer key just so I can verify that. So that statement for number 2 doesn't really make sense to me. So I don't, well, not at this moment. Oh, poop. So it is 2 and 3. Okay, so I would have missed this one. But yes, the answer would be 2 and 3 only. So use the chain rule to differentiate. Okay, so as I'm kind of backtracking here a little bit, so what I'm seeing is, okay, so what I'm seeing is y equals arcsine of x. Define dy dx. dy dx. I don't know. Okay, well, unfortunately, I'm just gonna move on because this is a weird problem to me. But I know for sure 3 is true because I'm implicitly differentiating the function. Okay, so that's what I did here, right? Yeah. Yeah, so I have to think about that one a little bit. So if you guys are interested in, to talking about this one, I would be happy to do that. Okay, which of the following expressions can be differentiated using the product rule? So that's not product, that's not product, that's not product. So there's our answer. Okay, 9-7, which of the following expressions find the use of implicit? So not this one, and not this one. So there's our answer. For which of the following functions of the quotient rule will be considered? Okay, not this one. So possibly this one, not that one, and possibly this one. Now this one can be rewritten as y equals 2 plus 1 over x. So that one is actually better to do without product rule, okay? But this one is totally a second times the derivative of the first minus the first times the derivative of the second all over second squared problem. So I would go with D. Slide 8. Okay, derivative 4 times. So y prime equals 2 times 1 over x, so 2 over x. Y double prime equals 2 times negative 1 over x squared. Y triple prime equals 2 times negative 2 times x to the negative third. And then that becomes a positive. And then y quadruple prime, so 4x to the negative third, that would be negative 12x to the negative fourth, which would lead me to my answer here. But let me just double check one more time. So y prime equals 2 over x, so 2x to the negative first. Y double prime equals negative 2x to the negative second, negative 4x to the negative third, positive 4, and then negative 12x to the negative fourth. There we go. Okay. And then the last couple here. The figure above shows a graph of f prime, the derivative of the function of f, at which of the 4 indicated values is... Okay, so this graph is the relationship between f prime and f double prime. So keep in mind, this is not a graph of f. And we're going to talk more about this in Unit 5. But this is not a graph of f. This is a graph of f prime, right? So we can't just look at the mouth of each guy and figure out if it's concave up or concave down. Rather, we need to compare the relationship between f prime and f double prime, which is, it's the slope. Do you get what I'm saying? So to get from f prime to f double prime, we need to take the derivative of it, right? So what they're asking us then is at each of these parts, where is the slope the greatest? In other words, where is it the most positive? So if I look at A, for example, there's my slope. If I look at B, that looks like my solution, and C is flat and D is negative. So C and D are out of the picture. So the answer would be B. Now, many of you would be tempted to write, I think, A as your answer, because if that was an F graph, then yes, we would say that the concavity there, the mouth, is the most positive. It's the most positive value. Whereas the mouth here would be negative, and here these are what we call inflection points where the concavity is 0. But we don't need to worry about that right now. Right now we're just concerned about, okay, where is the instantaneous slope the greatest? And here at B, there it is. All right, final problem, number 9. Let f be a twice differential function, f1 equals 3, dy dx equals that. What is the value of that? So we are taking a double derivative of an implicitly derived function, which has one little step that we want to remember. Now, when we look at this will take us to d squared y dx squared. So in other words, we're just finding the second derivative. And then we have to, well, we can bring the 4 out in front. And we have to remember that this is y squared plus 7x squared to the 1/2 power that we're taking the derivative of, okay? So that would be 1/2 y squared plus 7x squared negative 1/2 2y dy dx plus 14x. Something like that. And then at x equals 1. Oh, I'm sorry, just one additional step here. This can be written as 4/1/2 y squared plus 7x squared to the negative 1/2 times 2y, and then the dy dx 4 square root of y squared plus 7x squared plus 14x. So there is a long, non-simplified version of the derivative. There it is, okay? And so now we're considering the case at x equals 1. We know that y is equal to 3. And how do I know that? Right there. So all I have to do now is I need to put everything in. 4/1/2, and then let's do some mental math. 3 squared is 9, plus 7x squared is 7 to the negative 1/2. So that's going to be 1/4, but we'll come back to it. So 2 times y is going to be 6 times 4 square root. 9 plus 7 is 16. Okay, and then plus 14x is 14. There it is. Okay, so there's the big problem. And then at this point, it just becomes, a bunch of stuff we're solving out. So 1/2, 1/4 times 4, 16, 96 plus 14 is 110. So that just becomes 4 times 1/8, so 110 over 8. So does 110 go into 8? It does not. Well, hold on a minute. I think I made a mistake. 4y, okay, so 2y times dy dx plus 14x. Okay, looks like I made a typo here. So 14, 4, 16, 96 plus 14 is 110. 110 over 8, it does not divide nicely, unfortunately, right? Yeah, it does not. And 2, oh, there we go, 55. Okay, so there's the answer. All right, so enjoy this one.